Rules, rules, rules. Seems like geometry is full of them. But once you master those rules, you'll be well on your way to becoming a geometry pro. In this lesson, we'll look at the formula to find the area of a triangle. We'll also look at a popular triangle on the SAT, the right triangle. The formula for the area of a triangle is area equals 1/2 times base times height. Although you can always look for this formula in the formulas box at the beginning of a section, you're going to be using it a lot, so it'll help to memorize this one. Let's look at a triangle to explain this formula. The base of a triangle can be any of the three sides, but keep it simple and stick to the side that naturally looks like a base. Once you've chosen the base, you have only one choice for the height. The height is always the perpendicular line connecting the base and the angle opposite the base. Pro tip coming at you. Notice that while this definition usually means that the height is within the triangle, sometimes it isn't. For example, you may find the height featured beside the triangle, like in this figure. Here's an example of a triangle with a height of 5 and a base of 12. Notice again that the height forms a right angle with the base and isn't necessarily one of the sides. To find the area, we're just going to plug these numbers into the area formula. So this becomes 1/2 times 12 times 5, or 1/2 times 60, which is 30. Now let's move on to explore this rule in the context of right triangles and see if we can apply this knowledge. Do you remember what a right triangle is? If not, this will be a good refresher. This is a right triangle. Base and height are easy to identify quickly in the case of right triangles, no matter how the triangle is oriented. This is because the legs of the triangle are already perpendicular to one another. This makes it easy to solve for the area using the formula area of a triangle equals 1/2 base times height. How was that? Not too bad, right? Just remember to solve it step by step so you don't make unnecessary errors by rushing. All right, now let's talk about one last rule, the third side rule. This is a rule that applies to all types of triangles, so it's definitely a keeper. The third side rule just tells us that for any side of a triangle, its length must be somewhere between the sum of the other two sides and the positive difference of the other two sides. Let's take a look at a triangle and see what this means. We have two triangles, one with sides of 3, 4, and 5, and the other with sides of 3, 4, and 10. One of these could be a triangle in real life. The other couldn't. How can we tell the difference? Well, one follows the third side rule, and the other doesn't. Let's check the triangle on the left first. We're told that any side needs to be more than the positive difference of the other two and less than their sum. Let's check. First, we need to compare A to side C minus B, or 5 minus 4. Since 3 is greater than their positive difference 1, comparing 3 to B plus C, or 4 plus 5, we see that 3 is indeed less than 9. Next, we can compare B to side C and A. We know that side B has to be bigger than C minus A and smaller than C plus A. Since C minus A, or 5 minus 3, is 2, and 4 is greater than 2, side B passes the first test as well. Since C plus A is equal to 8, which is bigger than 4, it passes the second test as well. Okay, at this point we could probably say that the triangle on the left is real, but let's check that last side. C is definitely greater than A minus B since 5 is bigger than 1. And it's less than 4 plus 3, which equals 7. We can safely say that the first triangle is real. But what about the second triangle? Well, let's check one of its sides, side D against sides E and F. F minus E is equal to 6. Since this is bigger than 3, we can safely say that the figure on the right couldn't actually be a triangle. Okay, now that we have some more triangle rules down, let's do a little practice. This time, we'll do a pause and solve, so you can work it out on your own before we go through it together. Grab some paper and a pencil, and when I say pause, you'll pause this video and solve the problem. When you're done, unpause the video so we can make sure you know how to solve the problem and get to the right answer. Here's the question. The length of the base of triangle A is 12. If triangle A has the same area as a right triangle with sides of lengths 6, 8, and 10, what is the length of the height of triangle A? Our answer choices are A, 2, B, 4, C, 5, and D, 6 2/3. Now it's your turn. Ready, set, pause. And we're back. Did you get through the problem quickly and confidently? Let's work through this problem together and make sure we get the same answer. The first step, as always, is to underline the facts, circle the keywords, and label the answer choices. Now, we've got a question that mentions triangles, but it doesn't have any pictures. It's time to draw some triangles. We don't know the height of triangle A, but don't let that slow you down. Draw a triangle. Don't worry what it looks like. Label the base 12 and the height H, and let's move on. Now let's draw the right triangle. We know the sides are 6, 8, and 10, but which side goes where? The longest side of a right triangle is the hypotenuse, the side opposite the 90-degree angle. In this case, the longest side is 10, so let's label the hypotenuse 10. The other two sides represent the base and the height of the right triangle. It doesn't matter which is which. Let's label one side 6 and the other 8. The question tells us that the two triangles have the same area. Since we know the base and height of the right triangle, let's figure out its area. The area of a triangle is 1/2 times base times height. The base is 8 and the height is 6. A quick bit of multiplication tells us the area equals 24. So if the right triangle's area is 24, triangle A's area is also 24. Let's set up our area formula again. The area is 24 and the base is 12. So 24 equals 1/2 times 12 times the height. We'll divide both sides by 6 and find the height equals 4, which is answer choice B. So we have some new rules and a lot to work on. Because there are so many rules, chances are you'll just need to apply one to find the right angle on a problem. See what I did there? Try to look at triangle problems as your friends and keep that practice going.